Welcome to CSC 502T. I'll be teaching you computer networks. In this lecture, I'm going to explain some basic concepts about networking and various reference models. If you have any queries regarding the course, you can mail me on given mail ID. Overview of networking. Computer network. The main idea with the computer network is communication between different systems. Systems here can be routers, switches, or computers that are linked together so that they are able to communicate with each other using some transmission media like wires, fiber, or cables. The main purpose of communication is basically information sharing. Computer network provides communication that is reliable, fair, efficient from one application to another. Here are some of the examples of networks. Uses of computer networks. Computer networks are used for business applications like online buying, home applications like mail or chatting, mobile users like laptops, PDAs or mobiles. Business applications of networks. A network with two clients and one server. In this model, you can see the data are stored on powerful computers called servers, and these clients are connected to this server through a network. In contrast, the employees have simpler machines known as clients with which they can access the remote data. Suppose we want to pay the bills or check our bank accounts, so different users can access the same server to attain that particular information. The client-server model involves requests and replies. Here you can see client machine is sending a request to attain a particular information to the server machine, and server machine is in turn sending a reply or an acknowledgement to the client machine. Home network applications. Access to remote information involves interaction between a person and a remote database full of information. The second broad category of network use is person-to-person communication. Like chatting allows people to type messages at each other in real time. Third, interactive entertainment like games or movies. Actually, we have multi-person real-time simulation games like flight simulators. If games are played with goggles and three-dimensional real-time photographic images and moving images, we have a kind of worldwide shared virtual reality. Lastly, electronic commerce. Electronic commerce is starting to become more important in doing business with consumers over internet. Many companies provide catalog of their goods and services online and take orders online. Here are some of the examples of electronic commerce. Business to consumer, ordering books online. Business to business, car manufacturer ordering tires from supplier. Government to consumer, government distributing text forms electronically. Consumer to consumer, auctioning second-hand products online. Peer-to-peer, file sharing. Home network applications, peer-to-peer. In this form, individuals who form a loose group can communicate with each other in group. As shown in the figure, every person can in principle communicate with one or more other people. There is no fixed division between clients and servers. Lastly, mobile network users. Combination of wireless networks and mobile computing. Examples are notebook computers and PDAs, personal digital assistants. At many business airports or car rental return, clerks work in parking lot with wireless portable computers. They type in the license plate number of returning cars, which has a built-in printer. It calls the main computer, gets the rental information from there, and prints out the bill on spot. OSI model. OSI stands for Open System Interconnection Model, which means that every system participating in this model is open for communication with other systems. The model was first defined by an organization called ISO. ISO stands for International Standard Organization. It established a committee in 1977 to develop an architecture for computer communication. The ISO works on standardization of protocols. In 1984, the Open System Interconnection (OSI) reference model was approved as an international standard for communication architecture. This is how the OSI model looks like. OSI model is made up of 7 layers. So from top to bottom, or for what is closest to the end user that the user is interacting with, the topmost layer is, and the 7th layer is the application layer. This is the layer that the user is actually interacting with. If you are going on a website, the application layer is actually interacting with the user. So if you are doing an email, this is the actual thing you are interacting with. Underneath this layer is the presentation layer. The presentation layer manipulates the representation of data for transfer to applications on different devices. The presentation layer is responsible for the following services: data representation, data security, and data compression. That is, it is responsible to translate, encrypt, and compress data. As you can see in the figure, the text and data can be converted into various formats, that is encrypted format. You can see sound or video. In various formats, we can compress these sounds or videos. To make them more secure, we can encrypt the data, or we can encrypt our sound or video clips or visual images. Underneath this layer is the session layer. Session layer establishes, manages, and terminates session. Session layer is the layer that deals with the communication, creating a session between the two computers. So if you are going to a website, basically your computer at the session layer has to create a session with the web server that you are trying to access the data from. Two different communication modes exist for data transfer within a session connection. First is half duplex and second is full duplex. In half duplex, transmission and reception of information must happen alternately. While one is transmitting, the other one must only receive, like in your walkie-talkies. Now, full duplex. Full duplex communication between two components means both can transmit and receive information between each other simultaneously, like in your telephones. In your telephones, you can receive and you can transmit the information simultaneously. That's your full duplex communication. Underneath this is the transport layer. The basic function of transport layer is to accept data from above layers and split it up into smaller units and then pass these to the network layer and ensure all pieces arrive correctly at the other end. The transport layer is a time end-to-end layer all the way from source to destination. Basic transport layer services include flow control, that is buffering and windowing. Flow control. Once the connection has occurred and transfer is in progress, congestion of the data flow can occur at a destination for a variety of reasons. Possible options include the destination can become overwhelmed if multiple devices are trying to send data at the same time. It may become overwhelmed if the source is sending faster than it can physically receive. Now, congestion prevention. How the transport layer is responsible for prevention of congestion. The transport layer is responsible for providing flow control to elevate the issues of congestion and provide reliability in the data transfer. Two main methods for flow control include buffering and windowing. Firstly, buffering. Buffering is a form of data flow control regulated by the transport layer. It is responsible for ensuring that sufficient buffers are available in the destination for the processing of data and that is data transmitted at a rate that does not exceed what the buffer can handle, as you can see in the figure. Send segments with flow control. Here you can see a sender is sending the packet and is transmitted to the receiver. Upon receiving the packet, the buffer is checked. Now, if the buffer is full, stop signal is sent to the sender. If the buffer is not full, then using the transport layer, the go signal is given to the sender. And then sender further sends the next set of packets and continues till the packets are successfully transmitted. Windowing. Windowing is a flow control scheme in which the source computer does the following. Monitor and make adjustments to the amount of information sent based on successful, reliable receipt of data segments by destination computer. The size of data transmission, known as the window size, is negotiated at the time of connection establishment. It is determined by the amount of memory or buffer that is available. Suppose here, given a window size of 1, here you can see sender is sending 2 times and receiving the acknowledgement back 2 times, while given a window size of 3, the source sends 3 data segments to the destination and the destination sends an acknowledgement asking for the next set of data segments. Here sender sends the data segments 3 at a single time. Receiver acknowledges all the 3 at a single time with a single acknowledgement message and sender sends the 4th packet which is directly received. Underneath this layer is the network layer. The network layer determines how packets are routed from source to destination. As we know, if too many packets are present in the subnet at the same time, they will get into one another's way, forming bottlenecks. The control of such congestion belongs to the network layer. The quality of service provided, like delay or transmit time, is also a network layer issue. So this layer is more concerned about routing, which we are going to discuss in our next session. Underneath this layer is the data link layer. Data link layer attempts to provide reliable communication over the physical layer interface. The main task of data link layer is to transform a raw transmission facility into a line that appears free of undetected transmission errors to network layer. It accomplishes this task by having the sender break up the input data into data frames and transmit frames sequentially. If service is reliable, the receiver confirms correct receipt of each frame by sending back an acknowledgement frame. Data link sublayers. Data link layer has 2 sublayers, LLC and MAC. logic link control responsible for identifying network layer protocols and encapsulating them. Media access control defines how packets are placed on media. Lastly, physical layer. Physical layer is basically interface for transmission of information. It's concerned with all the wiring stuff. The physical layer is concerned with transmitting raw bits over a communication channel. The design issues have to do with making sure that one side sends a bit 1, it is received by the other side as a 1 bit and not as a 0 bit. It covers all the mechanical, electrical, functional and procedural aspects for physical communication. That is, all the wiring is involved in the physical layer. Such characteristics as voltage levels, timing of voltage chains or physical data rates, maximum transmission distance, physical connectors and other similar attributes are defined by physical layer specification. This is all about today's lecture.